Hello everyone and welcome back to my channel. In this video, we're going to talk about TDE. TDE stands for Transparent Data Encryption. TDE is a security feature that encrypts data addressed in databases. It is used to protect sensitive information stored on disk, including database files, backups, and transaction logs by encrypting them before they are written to the storage and decrypting them when accessed. A more detailed explanation of features includes encryption at rest. TDE encrypts data while it's stored on the database server's hard drive or other storage media, making it unreadable to unauthorized users who might try to access the files directly. Real-time encryption and decryption. TDE performs encryption and decryption operations on the fly as data is written to and read from the database without requiring changes to the application using the database. Key management. TDE relies on encryption keys to secure the data. These keys are typically stored separately from the encrypted data to further enhance security. Compliance. TDE can help organizations meet various regulatory requirements, such as PCI DSS, HIPAA, and GDPR, which mandate the protection of sensitive data. Now I'm going to show you how to implement TDE on your SQL Server environment. Please do consider to do this first on a testing or staging environment until you get acquainted with the whole process. Now, let's continue. Before we implement TDE in our SQL Server environment, we need to double check for any encrypted databases that we have. We need to query the sys.databases catalog. We pass a where clause where is_encrypted equals 1. Now let's get our values back. As you can see, we don't have any database that is encrypted. Now, we're going to double check for any database master key that's on our server. As you can see, here's a list of my databases. In this case, I can see my 4 system databases and a user database. None of them have a service master key or a database master key. Now I can proceed to create my database master key and my certificates. I'm going to proceed to create my master key. In order to do that, I'm going to use the master database. I'm going to pass on the parameter create master key encryption by password. This is a complex password. You can make it more complex if you wish to do so. Just make sure to store it for security purposes. Now we're going to create the certificate. To do that, we pass on the create certificate command followed by the name. And we also add the with subject option, which basically puts a comment on the certificate. This is a description that, depending on the version of the operating system that you run in your SQL Server, will have a different length. For example, if it's a Windows-based SQL Server, the length of this information will be 128 characters. If it's a Linux SQL Server, the length of this information will be limited to 64 characters only. Now, let's create a certificate. And we're done. Now we are going to assign the certificate to the TDE_demo database. To do that, we first change the scope to the database. Then we run the command create database encryption key, followed by the with algorithm option. In this case, we're going to use AES 256. Now, we have several options when it comes to the algorithm. We have AES 128 and AES 192. In this case, we're going to use AES 256, which is the most used for the purpose and the most secure as well. We used to have TDE 3 which right now is the least recommended due to security and performance issues. Finally, once we do that, we turn on TDE encryption for the database using an altered database and set encryption on. When we assign the certificate to the database, we get a warning. Now, this warning is specifically to the backup of the certificate. The reason for that is because we need to back up the certificate if we want to do a restore of the database elsewhere or on the server in case that something goes south. I'm going to demonstrate how to do the backup in a moment. Now, for the final step, I'm going to set the encryption on for the TDE_demo database. And now our database is encrypted. Now I'm going to show you how to back up the certificate. Basically, you pass on the backup certificate parameter followed by the name of the certificate. You specify a file location where you're going to have the backup of the certificate, and you also need to add a private key. The private key location and the encryption by password for the private key. Let's run the command, and it just completed. Now, the two files that I'm going to show you now, show right here, are necessary to restore your database. This is the certificate, and this is the private key. Now, we need to test this just to see that it works correctly. The way to do that is the following. We're going to do a backup of the TDE_demo database. In our case, we're going to switch to a SQL instance that I already have installed on this machine, which is like having another SQL server. We're going to test the restore without the certificate. An error is expected. We're going to import the certificate, and we're going to restore the database and query the data in it. Now we're going to do a backup of the TDE_demo database. This is going to be a full backup, as you can see, and it's going to have compression as well. So let's proceed. And the backup is completed. No error messages at all. Now we're going to proceed to restore the database, or at least to attempt to restore the database. But before we do that, we need to copy the backup and the certificate to the new location. This location on the right is the location of the new SQL instance that I had installed. So let's copy the backup and the certificate with the private key. Okay. Now, I'm going to connect to the new instance on the side. So you can see it on the Object Explorer. The new instance name is Euclid. Now, Euclid has no databases on it. It's brand new. I'm going to do the same on the SSMS window. I'm going to click here on the Change Connection, and I'm going to connect to Euclid. So, bear in mind that Euclid does not have the certificate or an encryption key. Okay? So, I'm going to run the restore, and I'm supposed to get an error message. But inside the error message, there's some information that will help me identify the certificate that I have for that database. So I run it, and this is the error message that I get. The error message states that it cannot find the certificate with a thumbprint. I'm not going to say this number is too long, but this is a thumbprint that it cannot find. Now, this thumbprint right here, as you can see in the comment, is a SHA-1 hash. So let's go to a query that I have here on the local machine. So I'm going to list my certificates, okay? Not the certificates on the Euclid instance because I have none, but on the main server. So as you can see, I have one certificate for TDE_demo. And in the end, there is a thumbprint. Now, this value here should be exactly the same as the thumbprint that shows on the error message. So I'm just going to copy that and compare it. Okay, as you can see, this value here is exactly the same as this value right here. So that way I can identify, in case that I have more than one certificate, I can identify which is the certificate that belongs to this database. This is good in the case that I have more than one certificate. But since we only have one, we already know which one it is. So let's correct the situation now. To do that, we're going to need to do two steps. We're going to need to create a master key on Euclid. Now, the master key has a password. It doesn't have to be exactly the same password as the master key on the source server. It could be a different one. What has to be the same is the password on the private key for the certificate. So let's proceed to create the master key first. And now let's create the certificate and let's pass on the password for the private key. Once we do that, we'll go back to the restore. We'll execute. And as you can see, that completed successfully. And just to double check, I'm going to query a table that's inside the database. And there it is. This query returns the name of the instance and some information on the table, as you can see. Now that we have TDE encryption enabled on Euclid, and we have the certificate for the TDE_demo, it means that we can take a full backup from TDE_demo on the source and restore and replace the one we have on Euclid. And we won't need to specify the certificate again. We do need to use the certificate if we're going to do a backup from Euclid and take it to another machine. Now, if you need to remove TDE encryption from Euclid, I'm going to show you exactly the steps that you need to take. It's 4 steps only. Now, the first step that you need to do is set the encryption off specifically for the TDE_demo database. The second is drop database encryption key for TDE_demo. Third, we drop the certificate TDE_cert. Last, we drop the master key. Once we complete that, it is good to restart the SQL Server services. We do that by right-clicking on the instance and selecting Restart. Yes and yes, because there's the SQL Server services and there's the SQL Server Agent services. Once that is completed, we can double check if there are any database master keys left behind. And as you can see on my screen, I have all my databases, but none of them have a database master key. Same thing goes for the certificates. If I run this query, there should be no certificates on any database. If you find this video to be useful, please like and subscribe or leave me a message and I'll get back to you as soon as I can. Also, the script that I used in this video is available on the video notes. If you want to, you can follow that link and go to my GitHub page. Please do remember, do not attempt to do this in a production environment. Do this in a staging or testing. Be safe. Thank you for watching.